Hello friends, myself Gokul Patil. Welcome to our YouTube channel. Today I'll talk one more important data structure from tree, that is binary search tree. We already studied binary tree. In a binary tree, the elements are organized from left to right. But this is very special kind of a binary tree, that is a binary search tree, in which there is a special way to search the element inside a tree. If I talk about a binary tree, in that there is no special way that we can search an element. If I want to search a particular element in a tree, then we have to traverse a complete tree and then we'll get a node. So it will take a lot of time, or we can say in terms of performance, it will take big of and time complexity. While in the binary search tree, there is a special way to search an element inside a tree. We'll see that how the element is going to be searched in the binary search tree. First, we'll talk about a binary search tree. A binary search tree is a tree that is either empty or it follows the following property. The first property is the left node is always less than the parent. The right node is always greater than the parent. And third one is right and the left sub branch are again follows a binary search tree. That means suppose this is the root. Any value which is less than root will be lies in the left sub branch, and anything which is greater than root will be lies in the right sub branch. Here if I write a 10, then anything which is less than 10 will be in the left sub branch, and anything which is greater than 10 will be in the right sub branch. So here I write 9 and here I write 11. So this is a binary search. Now coming towards, we'll solve an example so that you'll understand that how the binary search tree is been constructed. So first we'll take the element 50, which is a root. The first element is the root for this binary search tree. Then we'll add a next element which is 15. 15 is less than 50, so it will be in the left sub branch. So 15 will be added in the left sub branch. Coming towards the next element is 62. So 62 is greater than 15. If it is greater than root, then will be attached into the right sub branch. So 62 will be now a part of right sub branch because it is greater than 50. Coming towards the next element, which is 5. It will be compared with the root element. Now it is less than 50, so will be in the left sub branch. Again it is compared with parent node 15. It is again less than 15, so will be inserted in the left sub branch. So now 5 will be inserted after 50. Next element is 20. 20 is again compared with the parent, which is less than parent, so will be in the left sub branch. Then it is greater than 15, so will be added in the right sub branch. Coming towards the next element, 58. 58 is compared with the parent, so it is greater than 50, so will be found in the right sub branch. But it is less than 62, so we'll attach that node into the left sub branch of 62. Coming towards the next element, that is 91. 91 is being compared with the root element 50. 50 is less than 91, so that element will be in the right side. So 91 is compared with 62. Again it is greater than 62, so 91 will be inserted in the right sub branch. Coming towards the next element 3, so it is less than 50, it is less than 50, it is less than 5, so will be inserted in the left sub branch. Next element is 8. 8 is compared with again root element 50, less than 15, but it is greater than 5. So if it is greater than, anything which is greater than root will be in the right side. So 8 will be inserted in the right side of 5. Next element is 37. 37 is again compared with parent, so it is less than parent, so it will be in the right side, but greater than 15, so it is in the left side. It is greater than 20, so will be inserted in the right side of 20. Coming towards the next element 16. 60 is greater than 50, so will be in the right side of binary. So 60, it is less than 62, it is greater than 58, so 60 will be inserted in the right side of 58. Coming towards the next element, that is 24. 24 is will compare with parent, that is 50, so it is less than 50, so it will be in the right side. So it is compared with 15, it is greater than 15, so it will be in the right side of 15. So it is compared with 20, again it is greater than 20, but it is less than 37. So it will be found in the left side of 37. Sorry. So in this way, we can construct a binary search tree for any particular example. If you observe this particular binary search tree, then you understand that any sub branch, any left sub branch or any right sub branch is also again binary search tree. If you talk about this sub branch is also a binary search tree. 5 is the root, 3 which is less than 5, 8 which is greater than 5. So this sub branch is also again a binary search tree. So in this way, we can construct a binary search tree for any example. Now there is a second advantage of this binary search tree is that if I want to print node in ascending order, then also it is possible. If I use a traversal like in order traversal, in order traversal, this binary search tree is going to be print in ascending order. So we will see that also how that node will be print in the ascending order. In my last video, I also taught that how to print the node in order, pre-order and the post order. We will see only in order traversal for this binary search tree because I have to print this node in. We know that the sequence of node to be print in order is the node should visit or the root should visit in the second slot. So in order sequence is first it visit left side, then it visit root and then it visit right side. Here I write data, left, data and the right side. So first it visit left and it visit data. So we will focus on the node which is visit second. So first here I write some dummy links. To watch this video before you have to watch my last video which shows that how the tree has been traversed in order sequence, so that you can easily understand this particular example. So it visit first time, so we will not consider it. 15 is visit first time, 5 is visit first time, 3 is visit first time, 3 is visit second time. So it visit second time, so we will write it in the in order sequence. Now 3 is visit third time, so we are not going to consider. 5 is visit second time, so we will write in the in order sequence. First time, now 8 is second time, so we will write it 8. Then 8 is third time, 5 is third time, 5 is second time. So we will write 50 in the output. Then 20 is the first time, 20 is the second time, so we will write it 20 is the second time. Coming from 37 is the first time, 24 is the first time, and 24 is the second time. So we will write it 24. 24 is the third time, 37 is the second time, so we will write 37 in the output. All the integers. Then 37 is the third time, so we will write 37. 28 is the third time, so we will write 37. 50 is the third time, so now it is converting. 50 is now second time. So we will write it in the order sequence. 62 is the first time, so now we will consider. 58 is the first time, 58 is the second time. So it is second time. So it was its second time, so we will write in the output. Now 60 was its first time, 60 was its second time. So as 60 was its second time, so we will write it in the output. 60 was its third time, so we are not going to consider. 58 was its third time, 62 is visit second time. So we will write in the output. 91 is visit first time, 92 is visit second time. So we will write 91 in the output sequence. 91 visit third time, 62 visit third time, 50 visit third time. So this is the complete traversal of this tree, and we'll see that all the elements are printed in ascending order. So if you want to print the binary search tree in ascending order, we'll prefer in order traversal. So likewise, we have to operate a binary search tree. Hope you like this video. If you like this video, kindly like the video, subscribe the channel.